Hello and welcome. In this video, we'll cover the first part of section 1.1 in the textbook. Chapter 1, and in particular this section, will focus on definitions and looking at examples of studies. So the first definition that we'll see is data, and we'll be looking, and data is just collections of observations. Data can be things like measurements. So say if we were looking at basketball teams or basketball players, measurements could be the heights and weights of the players. We could be looking at more categorical data, so say the name of a team that a player plays for, and survey responses. So these are generally more open-ended and could be how they felt at any given point, whether or not they felt prepared and ready to play. And statistics is just going to be the science of roughly studying data, but also planning the studies to obtain the data, looking at how you're going to be analyzing and interpreting the data. But also a big part of statistics is how you present data to one another. How do you communicate this data in a way that it's clear and concise, and you're not going to mislead each other on the effects on the conclusions that you can draw from the data. So we have a couple more terms here. So a population is simply going to be the complete collection of all data. So this is usually going to be unknown. For instance, if we wanted to study the fish in a lake and understand whether or not they're healthy, things like this, we're generally not going to catch every single fish and study them. We're going to collect a sample, which is simply going to be some sub-collection of members of a population, and we'll just study those instead. Now, you can study every member of a population using a census. This would be collecting data from every single member of a population. This is not very common, but for instance, it's used in the US when we want to determine the number of, say, representatives each state gets. The Census Bureau will conduct a literal census and try to collect data from every single member of the population here being the population of the US. And in any statistical study, there will be a few parts, and our textbook splits it down into three parts. One is preparing for the study. Two is once you have the data, analyzing this data. And three is drawing conclusions from the data. So when we're preparing, we want to consider the context of the data, where the data comes from, and how it was collected. So I'm going to scroll down for a second and come back in just a second. But the context of the data is really understanding what the data are. Note that data is plural, so data are is the correct way to say this. So understanding what the data are and what is being investigated. So for instance, if I told you that in a study, say topical study at the moment, would be looking at number of antibodies in someone's blood after having been given a vaccine or having not been given a vaccine, we could understand some context that this is probably studying whether or not this vaccine is working, looking at number of antibodies in the blood. So just understanding the data and what the numbers mean is a pretty big part of statistics. And knowing the source of the data is also important because some sources may be inclined to include bias. So understanding whether or not the data is coming from, say, a stranger on Facebook, a more reputable source, say, a research institution at a university or at a private research institution, and whether or not these sources, for instance, were sponsored by people or organizations that would want the study to come out in a particular way. Understanding the source of the data is often important, but it doesn't necessarily invalidate the research. We should just always be always have our skeptics hat on so that we can make good decisions. And the last thing that we want to do is understand how they collected the data. Did the methods used to collect the data sort of implicitly give a little bit of bias? So for instance, one way to collect data is using a volunteer response sample. And this could be something like an internet survey, where when you go to a website, you are asked for your opinion on something. And whether or not you take part in the survey is up to you. You volunteer your response to the questions. And in doing this, whether or not you respond can include some bias. So for instance, if this was a political survey, maybe those who are more outspoken on their political beliefs will be the ones to respond to the survey, and the survey results would indicate that people are a lot more fervent in their political beliefs than actually are, because those that aren't just didn't take part in the survey. So understanding the context of the data, where it came from, how it was collected, this is important. And once you have sort of the bigger picture in mind, then we can begin to analyze the data, which can include things like building graphs so it's easier to visualize the data so we can understand it, exploring individual parts of the data. This could be things like understanding if there are outliers, if you are looking at average household incomes and there's one millionaire in town and everyone else is not a millionaire, then you could expect the one millionaire to really throw off some of the data. And then clearly the biggest part of analyzing data would be to use actual statistics, apply statistical methods to these things. And then the last thing that you'd want to do in a statistical study is look at the significance. And there are two pieces to this. There's understanding the statistical significance and the practical significance of the data being studied. So statistical significance is when you find results that were unlikely to happen by chance. So for instance, if you flip a coin and you get 98 heads out of 100 flips, this would be statistically significant because that's pretty unlikely to happen. However, if you got 53 heads out of 100, that seems pretty likely that getting 53 heads out of 100, it seems likely that that would happen. So if you were to get 98 heads out of 100, because this is statistically significant, we could probably make some conclusions, could probably draw some conclusions about the coin we're flipping, and that is probably not a fair coin. But if we get 53 heads out of 100, we can't really say that the coin is fair or not. This is not a statistically significant event. Only when something is statistically significant can we really draw conclusions about what's happening. However, when something is statistically significant, we can ask about the practicality. So whether a result can actually be used and whether or not it can have a practical effect on what we want. And the example in the textbook gives a story about a drug that was used to increase the likelihood of giving birth to a baby girl as opposed to a baby boy. And the drug had been studied, and it was found to statistically, and the increase in having a girl was statistically significant, as in the drug worked and it was not happening by chance. However, the practical significance was that it increased the chances of having a girl by 0.03%, which, practically speaking, isn't very big. So even though the drug had a statistically significant effect on your chances of having a girl, the practical significance of this effect was very small and was not very significant. And I will conclude section 1.1 in the next video.